Hello, kids. I am not there today because I am at home dealing with my 2-year-old's broken leg since he decided to jump off the couch yesterday. And, as the song goes, no more monkeys jumping on the bed. Now there's no more monkeys jumping on the couch. But I'm helping him out today because he can't walk at the moment because his whole leg's in a cast. So I'm going to walk you through our lab here today. It's pretty self-explanatory. I'm going to be following the exact same steps, but I'll give you a visual walkthrough of how that works. Just in case you have any questions, you can watch this video and kind of see how things go. First off, I am reading directly from the instructions, which are here. So if you have any questions on how anything works, consult the instructions. First thing you need to do is read the introduction because there's 2 questions you need to answer about bacteria and antibiotics, because that is what the lab is about today, is seeing how resistant bacteria are to certain antibiotics and how that will affect them in the long run in terms of natural selection, because it is their natural selection ability to be resistant to certain drugs and mutate that resistance that makes them a perfect candidate for natural selection to choose which ones are more fit to survive than others because our drugs don't work on them anymore. So we're going to take a look at that today. What you're going to be using today is you're going to be using these plastic discs to represent our different types of bacteria. You're going to have blue, yellow, and red discs. The blue discs are the ones that are least resistant. These are the ones that are easiest to kill. You're going to be starting off with 13 of those. The yellow ones represent our medium ones. They are going to be represented by being the normal resistance, our normal bacteria. So they're about the medium difficulty to kill. And then we got the red ones. These are the ones that are extremely resistant, the hardest ones to kill. Those are represented by by red, and you'll have 1 of those at the beginning. And that's basically the first instruction, is how many you should have out there. So read the first step of the instructions here. Number 2 explains how this is going to work. You're going to take this die, and this dice is going to tell you, based on what number you roll, what you're going to do as far as when you roll. And there's 2 different outcomes. If you roll a 1, 3, 5, or 6, you took your antibiotics on time, and you're going to kill off some of the bacteria. We'll look at how that works here in the beginning. If you rolled a 2 or a 4, you forgot to take them, so you do absolutely nothing as far as killing the bacteria. However, after everything, the bacteria is always going to grow. So let's see how our results are going to work here. You're first going to record the number of each type of bacteria in your body in Table 1. That has already been done for you where it says initial. So we're already going to go into the first round of the activity. So you need to roll the dice. There's our roll. We ended up getting a 5. What that means, according to our chart, is that you need to kill off bacteria. Now, here's how the killing of the bacteria is going to work. You're going to start by killing off the blue bacteria first, because those are the easiest bacteria in your body to get rid of. So when you go to your blue pile here of your 13 originals, there's our 13 originals there, you're going to take out 1, 2, 3, 4, 5. 5 blue ones just died. They go back into your extra piles somewhere else at your table. So you then will chart how many bacteria are left after taking your antibiotics. So for our blues here, now we would have 1, 2, 3, 4, 5, 6, 7, 8 blues. We would have still 6 yellows because we didn't touch those because we killed the blue ones all first. And we have 1 red still. When we put that into our chart here, we just add them up to get our totals. So we got 8 plus 6 plus 1. That would be, doing math, 15 since we killed all 5 of them. So we would have 15 total there after the first round. Now here's what's going to happen. Because bacteria are special in the fact that they're just constantly reproducing, we need to, in order for a day goes by basically. And when a day goes by, the bacteria grow. For each pile where you still have a color, you need to add 1 more bacteria to it. So for the blues, you're going to add an extra 1 for the next round. For the yellows, you're going to add an extra yellow. For the reds, you're going to add an extra red. Then you roll the dice again to see what happens on day 2. On day 2, we got a 1, which is going to be killing more antibiotics. So you go over to the blues and you can go 1, 2, 3, 4, 5. You kill off 5 of them. That leaves you behind with 4. We can put that in our data table over here with 4. We've got now 7 yellows because we grew, and we got 2 reds now because we grew in the red category as well. So now we're showing some of the growth, but we're still killing off some of the blue because we remembered to take our antibiotics still. So if you do some math going on there, well, that'd be 13 bacteria now total that you have, 4 plus 7 plus 2. So that's what you're going to do. Now, let's say you forgot to take your antibiotics. Let's say on the 3rd day, I'm going to make this be a 2. And the 2, it says you forgot to take your antibiotics, you do nothing. What that means by doing nothing is that you do not kill off any of the bacteria. So no blues will be killed off there. But what happens instead is that they're still going to reproduce. So instead of 4, all of a sudden, boop, there's the 5th one. The yellows are still going to get another one, and the reds are going to get another one. So when you go to add in your chart, everything is going to increase a little bit when you start adding things to your chart. So instead of having the, downward trend of things, since there is nothing, you're going to show the addition of those newer ones still, because they're still going to reproduce whether or not you remembered to take your antibiotics. So we just went up by 3 bacteria because we forgot to take our antibiotics. Now, you're going to finish this until you get all the way down till you reach round number 10. When you get done with number 10, you're going to then create or answer the questions that are on the in the worksheet here. There's some questions to answer. You're also going to create a graph of your data. So there's 4 things that you're going to graph. You're going to graph your number of least resistant over the days. You're going to graph the yellows over the days. You're going to graph the red bacteria over the days. And then you're going to give your total number. You're also going to graph that. This is a line graph, so make sure you do a line graph for it. The X and Y axis is already set up for you, so you don't have to worry about that. It does have on the X-axis only going up to 8 days, so that means you only need to go up to 8 days on your data table when you go to graph. But you should complete all 10 on the actual when you're rolling, because we want to see if going 10 days using antibiotics is really the necessary thing, or if there needs to be a longer process in case you forgot to take them or whatnot. If you have any questions, feel free to email me. I'll be back Thursday, not tomorrow, but Thursday, back with everything. So we can review everything there that we have. We'll continue on doing our stuff there. Remember, a quiz on Friday still. But yeah, you should be able to walk through it based off the instructions on there. So I will see you later.